My name is Tabitha Chebet, and today I'm going to present to you EduVision. This is a product from a project I worked on with my group. During the COVID-19 pandemic school closure, Mr. Musa found himself in a position he didn't think he'd find himself. Having to teach his 8-year-old daughter with ADHD mathematics. Sarah learns differently. She needs examples rooted in real life, not just numbers on paper. And yet every single day ended the same, with Sarah overwhelmed and with Mr. Musa frustrated, and with the mathematics workbook untouched. Mr. Musa echoed his worries to a parent. My child is smart, but I just don't know how to help her. This is a cry of a number of parents of children with learning disabilities. Not that they lack love, but that they lack the tool that they can use to effectively help their children learn mathematics and other subjects as well. So this is where EduVision comes in. EduVision is a co-teaching tool aligned with the national curriculum. It's not only aligned with the national curriculum, but it is also specifically developed to help children with learning disabilities. Among its key features are inclusivity, and offering a national curriculum aligned lesson plan, and also offering personalized support because each and every child learns differently. This application will be able to tune or be tuned or be able to offer them support in line with what their needs actually are. So the technology that we used or that we implemented while developing this was Kaggle, Python. Python is a programming language that we basically built this application on. We used Python in an online platform called Kaggle. We used PyTorch to train our neural networks. And we used scikit-learn to help split our dataset into training and validation sets. We used Hugging Face to access the transformer library. That's the library that we got our models from. The models you see below, that's Gamma 22B, Llama 27B, and Falcon 31B, which you all trained. We used Clipchamp as our XAI tool. That's our explainable AI tool, just to give us a visual of how these models actually reason and come up with their output. And we use Gradio UI in Hugging Face Spaces to actually come up with the user interface for this application. Hugging Face Spaces is the platform we deployed our model on. So out of these 3 models, we selected Falcon 31B as the choice for this application. So from start to finish, these are the steps that we followed. We collected data from a number of publicly available online platforms, such as the NCDC curriculum-based websites and disability-based websites as well. We collected this data, and using an LLM tool called Google Notebook LLM, we structured this into a table and formed a tabular dataset. This dataset was cleaned. That involved dropping rows and dropping certain columns that had inconsistent values. After doing all the cleaning, we then used another tool called Neo4j, another tool, a knowledge database, basically, to convert our tabular dataset to knowledge graphs. These knowledge graphs were then used as input for an encoder that we call RGC, an RGC encoder, which is actually a neural network. We trained the neural network on these knowledge graphs and then came up with embeddings. Embeddings are basically vectors, and we use these vectors to actually fine-tune our models. We used the embeddings to fine-tune our models and also trained them. After training them, we evaluated them and came up with our explainable AI results that actually just help us, like I said, help us actually understand how the model reasons and how it comes out with the output it gives us. It's just for transparency. So after doing all that, we also did a bit of inference in order to see what kind of output the model would give us, and then we deployed it on Hugging Face Spaces so that we could use it as a web-based platform. For our business model, we decided to go with the freemium business model. This consists of a free tier and a premium tier. The premium tier is the tier that's paid for, while the free product is available to anyone who's able to access the application. The free product comes with generic lesson plans, standard worksheets, and basic learning space setups. While the premium product comes with personalized lesson plans, adaptive assessments, and learner analytics, so that you'll be able to trace your learners' progress throughout the weeks and throughout the months. So we have two kinds of buyers. We have two kinds of users, free users and premium users. So we basically decided to also go with this so that we would also promote inclusivity, so that a number of households that probably wouldn't be able to afford this would also be able to use the application without having to pay for it. The target customers we have are households, since it's also targeting home-based learners, primary schools, any educators that would be interested in employing this in their educational institutions, and NGOs such as UNICEF. So for the future plans, we currently plan on validating this with inclusive education specialists and educators, and also parents of learners with disabilities. So the input we get from them will actually help involve our refinement process and help us fine-tune the model more and come up with more specific, and come up with an application that actually fits the user's needs more. Then we also plan on soliciting for funds from NGOs in order to help us fund the next leg of the process that we have to follow. We also plan on moving from the current platform we have deployed on to a platform that will support more scalability. This is just to support a larger number of users, because currently we aren't able to support a very large number of people accessing the application at the same time. We also want to do knowledge distillation so that the application will be available for people in resource-constrained settings. Thank you.